Okay, I think it's there on YouTube now. You can, yes, you can watch it on YouTube also now. Okay, so let me open the assignment here. Your roll number.ipnp. Okay. And I can share my screen. I hope you can see. Okay, please ask your question now. You're saying 16 here. Yes, please ask Yash.
Yes, it is 16, sir. I can see. I can see on your screen. Hello, am I audible, sir?
What's your question?
Sir, it is 16. I can see on your screen. Nth value is 16.
Yes.
Yes. So in the forum, the people are asking a doubt with n value equal to 12. So I was getting confused with that.
Maybe somewhere down there was 12 somewhere. I don't. Here was a small mistake. I think this was posted that resampling is not required.
Yes, sir. Yes, sir. That update is there. There's one more question, sir, that I wanted to ask. Sir, in the question of MA filter, I came to know about the term transient. So the output that you gave, I also created a forum regarding that last night. So the output that you gave, it is with transient. So do we have to consider transient, or do we have to remove that?
Transient means? You mean at the corners, right? This corner and this corner.
Yes.
So basically, if you do DSP, I told in the forum also that we do use just a minute. Give me a second. Just give me a second. Just give me a second. Yeah. Okay. Okay. I'm sorry. Now am I audible now? Chat. Yeah. So yes. So transient response can be considered because I think I wrote in the forum yesterday that we do consider zero padding. So zero padding essentially means it takes care of transient. It assumes that X was 0 before and later after the given signal.
So sir, that means we have to match the output with yours only that you give, right?
Yeah, that's why I gave my standard output that, okay, because there may be many questions, so at least this figure will help you to know how things are done. Because it means you can do in so many ways, but this is the way which I have shown so that you can follow this.
Okay, sir. Thank you, sir.
Yeah. I will read out some questions from the chat window. There is one question from Shubham Gupta. He says, does downsampling by factor M means that we have to take one sample out of first M samples and then one sample from the next M samples and so on? No. Okay. Yeah, it means, okay, you take the 0th sample, then mth sample, then 2M sample, 3M, 4M, like that. Let's say here, in our example, the m was 2. Where is it? Yeah, m was 2. So we have taken 0, 2, 4, like 0, 2, 4, 6, 8, 10, 12, like that. So this is 0.64, and this is about 0.64. Yeah. So downsampling by m means you take 0m to m3m. Okay, let me read the second question from Saksham Gupta. He says, in the sawtooth waveform, the points 0 and 1 happen to be at the same time instant. Then how come the value of 0 and 1 appear at different values of n? Maximum value of plot can never be. Very good. Good question, Saksham. Very good question. So yes, in the continuous sawtooth waveform, you will see just before your time period, T naught, you will have a value of 1. And at the time period, you will have value 0. This is in a continuous time waveform. And when you discretize it, yes, you can never get exactly 1. But I have written here that you have to satisfy this condition, which is, where is it? Yeah, your maximum value should be equal to 1. So basically, I am normalizing your signal so that this value becomes 1. This is the concept of normalization, which I want to tell here. Normalization means, so it's written here, amplitude should vary between 0 and 1, and x0 should be equal to 0. This part is clear to you. And then maximum of x should be equal to 1. So it should be equal to 1. And how do you achieve it? You achieve it by normalizing your signal appropriately. Normalizing means multiplying with an appropriate factor. Next question is from Shubham Gupta. Then if n upon m is not an integer, then we have to take output ceiling of n upon m samples. Ceiling or floor?
So we can take ceiling also and floor also. Like both option can be find out, because at last there will be window, and by there will be some elements left. So we can take one element from that set of elements.
No,
So,
you can't randomly take. No, you have to take 0, m, 2m, 3m. If 3m is not there, let us say m is 5. So you take 0, 5, 10, and then 15. If let's say the signal is only up to 13, you don't have 15. So it will be only up till 10. 0, 5, 10.
yes, sir. But if let's suppose n is 5 and m is let's say 2,
Okay.
so we have to take 0th sample, second sample, and 4th sample. So in this way we have taken 3 samples. So n by m is 2, and ceiling of n by m is 3. So in this way we can take ceiling of n by m samples.
Let me do it again. So tell once again. So your n is how much?
Sir, n is 5.
N is 5. Okay. Then
And m is 2.
M is 2. Then your n upon m will be equal to 2.5. So you will say 2.
But we can also take 3 samples from.
Yeah, you're right. You're right. So it will be 0, 2, 4. 0, 2, 4. Yes.
Yes, sir.
Yeah, you're right. So you will take the ceiling. Okay.
So we have to output the number of samples is equal to ceiling of n by m.
Yeah.
Okay. Thank you.
Thank you. Next question. I think many people have questions regarding programming. So this is the first assignment where I think I gave everything. Like this function was given to you for plotting discrete values. This function was not used anyways in the assignment. Then generate sawtooth. This is very simple code you have to write here. I think it's very easy and you can do it. And then I have given this example so that you run a test case and see this is what you are getting. Downsampling, very simple code you have to write here. I think the structure is given to you. So even if you don't know Python, this is a nice platform to learn. Anybody has any questions regarding Python, please feel free to ask. Don't feel shy or anything, because I know many of you might be doing Python programming for the first time. Okay, now next, Shubham Shivastava is asking, please extend the submission deadline by a couple of days, as we had quizzes this week and I need more time in understanding matplotlib. Generally, I won't encourage extension of deadlines. Today, whole day is there, spend time and do it. Today you have, I think, almost 12 hours to do. That is sufficient, right? For one assignment, 12 hours, more than sufficient. Matplotlib is very simple. Okay, let me go to this function. So if you see this one, first line, just ignore. These are some very specific lines. You want to do something, just look up at Google and find out what is the package and all these things you don't have to remember. I don't remember that matplotlib ticker, max and locator. These things, even I don't remember. Whenever I need it, I just go to Google and do this. This is what I want to do. I just type in Google and then Google tells me this is the function you can use and I use it. Now, what important function you are using is this. These three functions are something which you can try to understand. So this is a stem plot. Stem plot means this thing, that it starts from the root and goes up till the value, and then there is a dot there. This is a stem plot. And this plot is a normal plot. Then, okay. So stem plot means then this is the x-axis, whatever is there on the x-axis. These are the values in the x-axis, 0 to length of x. These are the values in the y-axis, the values x. X is a vector which is having those values. And use line collection. I used this because if I don't use it, it was giving some error. Means some warning was given and it was saying that for the newer version of Python, use this. So I just added this line. This line is not is not something to remember. What you have to remember is only this part, that what kind of plot you want, your x values and your y values, and then your x label and your y label. That's it. Nothing else. Other things you can ignore. They are just go to Google and search. Okay. Next question by Anshul Rai. Do we have to seed the noise? Otherwise, it will vary from person to person. Yeah, you can seed it, but I don't see it as important. No problem, even if it varies. No problem. Even if it varies, no problem. Because anyways, I won't be using exact noise values given the seed, because people may use different functions to generate, Gaussian noise, right? So that is all right. No need to use a seed, but if you want to use, you're welcome to do it. But I have no problem. Ankur says, I have watched videos, not able to get the coding part. Ask questions, Ankur. Ask questions, whatever questions you have. Sunana is asking, the audio, I'm unable to play it after writing and adding noise. Okay. So are you able to do it after writing without noise? Just read the audio and write the audio, same audio back. And you should be able to hear the same audio, right? If you're not able to do it, this means there is some problem with your programming. If you're able to do it, then very good. You should be able to hear the same sound, means indistinguishable. The sound earlier means the original audio, hari.wave, and then you read it and write it, hari.wave, that both should be sounding same. Now, after adding noise, okay, that is, if you know how to write the sound after adding noise also, you can write it. Okay. So there are, I have written here, wavefile.write writes int 16, and you have to convert from convert x from float by dividing with max x and multiply. So basically, some scaling, etc., has to be done. I have posted a link on, I think it was on Mookit forum, that there is a website called Stack Overflow. Whenever you have any questions regarding programming, they have good answers. So I have posted one answer from there, that how do you do this scaling and all. Okay. So this is just something technical. Just search on Google and do it. You don't have to remember the 32767, these values remember. What you have to remember is the concept that these audio waveforms are actually a vector of numbers, and how do you deal with these numbers? Proper normalization has to be done and things like that. Next question is, yes, the solution will be given tomorrow, because tonight is the deadline. You have 12 hours. After 12 hours, and then by tomorrow morning I will release the solution. Next is I am using Collab import drive to mount. That's all right, Anadi. If you are using Google Colab, you are importing your thing, no problem. We will not be using Google Colab for evaluations. You'll be submitting your IPython IPNB files to us, and we'll be evaluating it ourselves. So we won't be relying on Google Colab. So don't worry. What is the space in that NumPy array of space in generate sawtooth function? Generate sawtooth function. What is that space? Which space? Could you please ask your question, Sumit?
Sir, actually it is not space, sir. I am asking about, sir, it is asking that array of SHA. Yeah, sir. What is array of shape? Like shape, I don't understand.
Okay. So you have any NumPy array, a NumPy array. Okay, I'll use the end of this thing. Let's say I define, okay, first import NumPy. I will say x is equal, or maybe let's say x is equal to np dot ones 5. And I say print x. So what is xx? Basically, it's a NumPy array of length 5. And if any array is given to us, I want to see what is the shape. So shape will be 5, comma nothing. Basically, it's a one-dimensional array of length 5. This dimension is 5. So it's a vector of length 5, basically. And if I say xx dot ndim, this will show me the number of dimensions. It has got only one dimension. It's a tensor of order 1, right? Okay, any other question you have? Okay, could you explain how F0 is found using autocorrelation? In the slide, you say we consider the maxima, but the example you also gave as a maxima at n equal to 8. Do we see the largest maxima? Yes, good question. So basically in real life, your curves won't be exactly periodic. They will be, okay, even if it is exactly periodic, but your autocorrelation will not be having only single peak. So yes, you have to find the maximum peak. There are many, so autocorrelation basically tells you the similarity, right? The first cell is overlapping the second cell, you get a peak. But how high is this peak? Ideally, this should be the highest peak. In real world, it may not happen, right? So I think these issues are there which you have to think about. So if you use autocorrelation, these issues are there. But generally, the highest peak will give you the F0. Highest peak will be the T0. But because of noise and because of other factors, because this is not an infinite length signal, it's a finite length signal, there will be some effects like that. There will be some effects, length effect will be there, and then the signal will have noise, or the two cells may not be exactly same. When I'm speaking, it is periodic, but not exactly same, right? So because of all those factors, but generally it is true that generally means for clean signals. But let me tell you the truth, to find F0 from real world signals, I don't think anybody uses autocorrelation. Autocorrelation is such a bad measure. There are better measures. Let's say some people use spectrum. They find the spectrum and try to find the peak there. Even there can be some mistakes, but then people make use of context. They will see not just in one window, but consecutive windows, where is the peak, like that. Many tricks have to be employed, but for this current assignment, take it as the maximum peak in the autocorrelation. So yeah. Okay, so let me tell you, Shubham also asking same question. So you have to do something intelligent to find it more robustly. So you have to do something intelligent. So let me see how you do it. Yeah, do something intelligent to find it reliably. This example which I have given you is a simple example, simple periodic signal, no noise, nothing, very simple. So for this, it is easy to find. But here what I want to see is, if you understand how do you compute autocorrelation, how do you know if your autocorrelation shift is this much, then what is the corresponding F0, all these conversions, these are the things which I want you to get a feel of, and how F0 is related to the T0, the time period, how it is related to the sampling frequency. All these things are important for you to learn. And if you understand those things properly, then you go to the next part, which is, okay, how to estimate it more robustly. Using autocorrelation, can you do something? Autocorrelation will have spurious peaks, as you are mentioning. Spurious peaks means those which are not because of F0, but because of some other factors. How do you ignore, or how do you eliminate those peaks and get to the right peak? Okay, now next question is, why 32767? Okay, because int 16, as I told you that we are dealing with, why do we use quantization? Because we have fixed number of levels, right? Fixed precision. So the int 16 numbers, the container means because the numbers are saved in a memory cell, right? In a memory, binary memory spaces. Those spaces, let's say if I assign a fixed number of bits, so you will have 2 to the power that number of bits, 2 to the power that number of different numbers which it can hold, right? Let's say if I have 3 bits, it can be 000, 001, 010, 011, 100, like that. So you will have how many numbers are possible to save in these 3 bits? 2 to the power 3, so 8 numbers. Only 8 numbers you can save in this memory cell with 3 bits, right? So when we use int 16, it has got some fixed number of bits. You can compute how many are there of some I think 16 bits, right? Okay, I don't remember. But, 16 bits will be too much. Okay, just check something like that. So int 16, if I'm using, then it has a fixed number of bits, and then based on that many numbers it can save. So it cannot save a number, let's say if it has got 16 bits, then it cannot save a number, let's say to the power 17. That number it cannot save because it does not have that many numbers. So what happens? So int 16 can have only minus 32767, 2 plus 32767. That is the limited range. That's why we normalize our range to match this range. Okay. What are you plotting in the last part? Manoj is asking, which last part? This one? Yeah, it looks like this is X. Oh yeah, this is X again plotted. I just plotted this so that you can see the two things next to each other. This is a plot of X and this is 2.5. So you can see how from here you can tell this is 2.5 F0. 2.5 hertz, right? I think this is units are important, hertz. So there is some conversion required. How do you go from this periodicity using your sampling frequency to this number 2.5? Yeah, that's it. Okay. Can we also use FFT for calculating F0 for this assignment? Yes, you can use FFT. You can use spectrum. How do we have to find F0 for hurry dot wave? If you can do that, that will be very nice. Not for the entire song, but take a small window. Let's say 20 milliseconds window. 20 milliseconds window or 30 milliseconds window where the periodic part is there. There you can find out F0. But what you will find is that this method, the raw autocorrelation, may not give you right answer. So you have to do some tweaking or some filtering to be able to get the right answer. Next question is adding Gaussian noise and lighting audio. Am able to hear the noise like we used to do on radio with a JHSS sound. After adding more noise to the original audio, the question is the output that you gave ours may or may not match. I am adding randomized Gaussian noise. Yes. I mean, the aim is to add noise which is happening. So guess it's right. Yeah, you have to add noise and that's it. Of course, noise will be noisy, and since we are not using any seed value, everybody will be having different values of the noise. That is all right, but it should be Gaussian in nature. Okay, any more questions? I think somebody asked that he's able to now. He's not able to understand the coding part. So ask questions. What thing is not clear? Please ask questions.
Hello, sir.
Yes.
I'm audible. Sir, I have one MA filter.
MA filter, yes.
Hello.
Yes.
So in MA filter, the formula is given y of n equals to summation from 0 to m minus 1 x of n minus m. So for y0, we are we are adding the values of x0, x minus 1, and x minus 2, and we are doing the average. We are doing the average by m. So our output should be from x0 to x15, means total 16 values, but in output there are total 18 values from 0 to 17.
Okay, because
why is it so?
Yeah, I let me tell you the answer. That's why I wrote in the forum also that we are using zero padding. So let's say, what is the length of x you said?
Length of x is 16.
16. It goes up till 15, 0 to 15.
Yes, sir.
Let's say my n is 16 now. So if my n is 16, x of 16 is 0, but x of 16 minus 1, which means x of 15, that is non-zero. X of 14 is also non-zero, like that. Although
Okay,
x is 0, but previous values are non-zero.
Okay, sir.
And once you cross this value, which is 16, once you go to 17, then everything will be 0, because x of 17 is, or x of 18 is 0, x of 17, x of 16, all three are 0. So y will also be 0. So here, after this 17, everything is 0, 0, 0. That's why we are not considering it.
So, sir, after 16, we have to pad m minus 1 values to calculate those 16 and 17. Okay, sir. Thank you. And one more question regarding with write audio. So in write audio, it is written that we have to divide the value of x by max of s, max of x, then multiply with 327 and 67. So the x means when we are reading the file, the value of x, and when we are writing the file, the value will not be same, because we are adding one more term, that x equals to x divided by max of s. So it will amplify the sound, I think.
Yes, you're right. You're right. But it will sound the same, little louder, but
yes, yeah. Okay. Okay,
correct.
thank you.
It's amplified. Okay. Any more questions?
So one more question. In the last question, it is given for f0 estimation. So when we are doing the auto correlation, will we find the peak at the first wave? Like from at the 0th position, it will give the maximum that correlation value, but after we are getting that small value, then again we are getting larger values, then again we will get some small values. So from negative slope to positive slope, again we are getting the negative slope. So will that from positive slope to negative slope, it will give the peak value or not? Because I'm just confused a little bit here.
So yeah, if you look at the autocorrelation plot, it will be okay at 0 you will get a maximum value, and then values will be degrading, and then again after some time it will start rising, then again degrading, and in between there will be much noise. It might be spiky in between. Generally for real world signals it will be very spiky, and you will get some spurious peaks there which don't correspond to f0. But what corresponds to f0 is after this big dip, when it again rises, there will be a large value which corresponds to f0. You can look at the shift and then corresponding f0 if it is matching. Right?
Okay, thank you, sir.
But you have to do some cleaning, because in real world signals you will get some, like let's say if I add a noise to this signal, then it won't be like very clean. It will be something noisy, peaky.
Okay, sir. Thank you.
Some smoothing you might try. Okay, next question. In the last part, I am getting peak at 0 Hertz and next peak at 2.5 Hertz. I'm ignoring the peak at 0 Hertz. Is that okay? Peak at 0 Hertz means you are matching the same signal with same signal, right? No, 0 Hertz. Okay, so you're saying at in the spectrum, in the FFT. Yes, so zeroth in the spectrum, 0 Hertz means what? Look at the formula. Your x of k, capital X of k is summation xn e to the power 0. It is basically just summation over all xn. So it will be a constant value. The DC value, basically the average value, you can say. I don't know if it is average. We're not dividing by 1 upon m. Just look at the original formula. I think 1 upon length is not there. 1 upon n is not there. So then in that case, it will be just for sum of all the values. So yeah, it's called the DC value or the average value. Okay, now Rakesh is asking, can I directly use np.convolve for convolution? The answer is yes. We have allowed in this assignment that you can use Python NumPy. Use only NumPy library for computing and signal processing. No other package allowed. But we are allowing you to use scipy.io wave file, but no other package other than NumPy. So since convolve is there in NumPy, you can use it. When taking the FFT also, you can use NumPy. You can use the FFT function of NumPy. In downsampling, if f is not an integer, it returns none. Then is it not give error when we plot the signal? Yes. Yes, if it is a downsampling. Yes. If your m is not an integer, it should give an error, and plot discrete.y won't work. So you have to add here, if y is not none, then right, you can add the simple condition. That's it. Right? Okay. Any more questions? So if there are no further questions, then we may stop here, right? And if you have further questions, ask on Mookit forum. We'll take it from there. And whenever you have questions, you write on the Mookit forum that you need an extra discussion hour or a doubt clearing session. We can arrange it. It's mostly on Saturdays, because Saturdays you will have more time. Okay. Thank you very much. Then we can stop here.
Thank you for clarifying.